Welcome back. This is, I guess, week 6 of our CAD class. And great to see you all again. As you might recall, last week I left off and we were trying to introduce this sprocket project. And we kind of started to discuss some ideas about how we might approach this, specifically how we're going to make this sprocket shape. So last week, some of the discussion points that were mentioned, I always like to ask, what shapes do you see whenever we try to make a new object? And what we decided on is like, we see like mainly there's one big circle that makes up the body of the sprocket. And then there's the teeth of the sprocket, which we're going to model kind of like triangles. And other things, I don't think anyone pointed this out because it's not like a critical feature of the sprocket, but what you'll see with most real like mechanical parts is they have some pockets or like empty spaces inside. And mostly that's for weight saving, to make the part lighter, because for most applications, you like to have your components be as lightweight as possible. So we're not going to be copying any particular sprocket. We're just going to have this general shape in our minds, and then we're going to try to recreate it. So before I get started, if you have any questions, if you have trouble hearing me, if I'm talking too fast, if you can't see my screen, things like that, please ask right now. And if you don't have any issues to bring up, then let's get started. Okay. Great. So hopefully where we left off last week, you all created a new project, named it something like Sprocket Project or week 5, something along those lines. So whatever you created last week, that new document, maybe some of you have made an attempt to start the sprocket during the week, which would be great. Just make sure to start working on that document, because later on, we're going to assemble our thing together. And when we do the assembly, it'll be really convenient if all our parts are in the same document. And we'll jump right into it. What's the first thing that we do when we want to create a part in a part studio?
Sketch.
Great. Thanks for answering. Feels like I'm in a real classroom or something. So we create a sketch.
I thought we were using the top plane.
You could. It doesn't really matter that much. In some senses, like the only thing that'll really have an effect on is when you bring your part into your assembly, it'll by default orient it in the same way that you have it oriented in your part studio. So
I'll probably just do front because they'll make it horizontal instead of vertical.
At the end of the day, it really doesn't matter. It's a matter of preference at this point. And body of the sprocket, as we talked about last week, it's going to be a circle. You can see I missed the center there, but I'm going to put my circle on the center, on my origin. And that's using my relations, specifically the coincident relation.
How big is the circle supposed to be?
Great question. On a real bike, you'll probably see it's going to be a couple inches in diameter. Really depends on what the sprocket's being used for. And since this is just a machine that doesn't do anything, it's just a sprocket on handles, it's really up to you. So feel free to pick any number. I'm going to pick some made up numbers. You can use the same ones, you can use your own. It doesn't really matter. The only time the dimensions will start to matter is when we start making other parts after the first part, because then we need to make sure that these parts will actually be able to fit together. And that's where kind of we need to make sure our dimensions are logical with respect to each other. But right now, since we're starting on a fresh new page, there's really no restriction. Maybe I'll make it 3 inches, which would be like this big in real life, thereabout.
Wait, 3 inches?
My default units are in inches, as I may or may not have mentioned. If
Mine's so small.
And from here, now we're gonna look towards the second part of the sprocket. We
Oh,
have the
mine is
body.
centimeters. Bruh.
What you can do, I believe, is specify the unit you want by typing in either IN for inch or cm for centimeter. So for example, if my default units are in inches, but if I wanted to type something in centimeters, I could type in 2 cm, and that will automatically convert it to inches. So 0.787 is 2 centimeters.
Wait,
I believe it also works for like meters or millimeters. Maybe
wait,
like
three, 3 inches is 7.62 centimeters.
or that was just an example. For example,
No, because I put in 3 IN and then it said 7.62.
in that case, it probably is that. Let's find out. There you go. 3 inches is 7 centimeters, 7.62.
Okay.
Yeah. And that's a common feature in most CAD programs where you just type in a unit and you don't have to convert it yourself. The program will just take care of it. So good thing to bring up. So the next part, now we're going to think about how we're going to put the teeth on this sprocket. So the kind of hint that I gave you last week was that we're not going to model every single tooth on the sprocket because that would be really annoying. We'd have to do the same thing, maybe like dozens of times to create our part, and we'd have to create all those relations, all those dimensions. It would not be worth it. No one would ever design
You
sprockets.
just create one triangle and then when you put it in the thing, when you put it in the assembly thing, you duplicate it a ton.
Almost. It's a similar idea, except the duplication part, as you call it, is going to happen entirely in this sketch. So what we're going to do is we're going to sketch just one unit of the thing that we want to pattern, which is the tooth of the sprocket. And that's kind of like a triangle shape, maybe just a pointed part. And to make that, I'm going to use my line tool. And so there's a lot of different ways that you can go about this. What I'm going to do is I'm going to, I'll draw some lines and I'll explain how I'm going about thinking about it. You're free to try your own method, depending on what feels the most right to you. But for now, let's just try making 2 lines that'll form a single tooth, a single unit of the sprocket.
Does it have to be symmetrical?
Usually it would be.
But can't you like, isn't there a way that you can make it symmetrical without trying to?
Sure, one way would be to make these two equal to each other. And then I believe that's sufficient to make them stay like symmetric. Although I may be wrong. It seems like that's enough.
I meant like, how do I make like it equal to the next triangle? Wait, can't you? What does copy sketch entities do?
I guess it depends. I'd imagine it's similar to like a copy and paste function on anything else. So you create a second version of the
Oh,
thing that you copied. Yeah.
I feel like my wait.
So we'll make one of these triangles, and then I'm going to do something that may seem a little odd, but I'm just going to create another pair of lines that go from the center of the circle to the points on these triangles where it meets the circle. So I kind of created a bit of a kite shape here.
Why do you have a kite shape?
And the reason I do that is,
So are we supposed to make a kite shape?
yeah, if you don't have an idea of like how to make the whole thing, I'd suggest trying following along and seeing how you feel about it. If you have an idea and you think you can do it, go ahead. Feel free to do whatever you want.
Do the kite? Like,
Yeah, and what I'm going to do is I'm going to take these bottom lines that I drew, and these are going to be my kind of construction entities. So I'm going to use my construction tool. I'm going to first select those two lines that I drew and just make them construction lines. And as you recall, the purpose of these construction lines is to create a reference, right? It's not going to be part of the final part geometry. It's not a boundary of my part. It's just a line that I'm creating for my own convenience so that I can use it as like a reference to create dimensions, for example, and things like that. And the reason I created these construction lines is because I want to dimension this angle. And I can put in any number I want. And you can imagine it's easier for me to think about this in terms of angles, right? If I just created the dimensions, maybe like an X and Y dimension for this point, for example, what would happen is I'm not really sure how many of these sprocket teeth will like perfectly fit into a full 360-degree circle. Instead, if I use this like angle tool and tell it how much of the circle the single tooth should take up, then I already know before I even start that there's going to be, 360 divided by 20 is 18 teeth, for example. Say I could also make this like 36 degrees, make a really wide tooth. This would be a very useful sprocket, seeing as the tooth is so wide. Can make it something like,
I don't understand how to make the kite shape.
sure, all I did there was use the line tool. So just like we drew arbitrary quadrilaterals in week 1 and 2, I just take my line tool and I do something like that. Except, of course, this point I put it on the origin, and these points I made sure were on the circle. So now that I've done this, I almost have what I need, which is like my unit cell, so to speak, my single tooth. And I just need to make the rest of it black. So in my case, these two construction lines that I drew, these have already been turned black because the first one is vertical and the second one is 12 degrees from vertical, which means that they're fully constrained, right? There's no other way to be 12 degrees from vertical except to be this exact line. So that's that. And the last thing is how big this tooth is going to be, right? So I'll need another dimension for that. Remember that I already made these two lines equal to each other, which you should probably do because it's going to be true for most real sprockets.
How do you get the degree how do you get it to say the degree measurement?
All right, so the dimension tool, it's the same one that you always use. It's D on your keyboard or this one in your toolbar. And the way we tell Onshape that we're trying to make a degree dimension or an angle dimension rather than a length one is just to select two lines, one after the other, that are not parallel.
But mine's not turning black. Mine is not turning black.
So if these are not black yet, I'm in the same boat. And if these are not black, what's potential causes are maybe one of them is not vertical.
What do you
Maybe-
mean? One of them is vertical.
Make sure that it has like a vertical relation on it.
Like, do I just click it with a vertical?
You can do that. That's just to be safe. Maybe it is already vertical. The other thing I'd check is to make sure that the endpoints are actually coincident to the circle using your
Okay,
coincident
now it's
relation.
black. Yay. Now it's black. Yay.
And as I was saying, the last thing I'll do is just dimension the
Can I make
tooth.
mine 10 degrees?
You're free to do as your heart desires. I won't stop you. I can't stop you. And so after I put a dimension on the tooth, in this case, I did like the, I guess the flank length of the sprocket tooth, and I just gave it some arbitrary
The
number.
length of a sprocket tube is 0.25.
In reality, this would not work at all as a sprocket, just because it really doesn't have a way to grab the pins of a chain. But I'm doing this to give you the general idea. And if you want to create a more realistic sprocket, there's plenty of textbooks and papers out there regarding the proper curves involved in a sprocket tooth.
What is
The
like 0.25 the amount, the how much it actually is?
I don't know what you mean by actually. This is just what I had made up because it looks pretty good in my opinion.
But how is yours so flat? Mine is really, oh, it's because you have 12 degrees. Oh. Oh yeah, that makes more sense.
All right, you're free to choose your own numbers. Just make sure, you know, yeah, you're always, yeah, don't worry about it. All right, so
It's 0.25 inches, right?
yeah, if you're using inches and are using a similar set of dimensions to what I'm using. Yeah, as you work on this as an aside, yeah, if you're actually interested in modeling like realistic sprockets, there's a lot of interesting math involved. It seems from this cursory search that they have what's called an involute profile. And so involute is like a curve that has an interesting property where if you have two meshing gears, for example, or in this case, it's a sprocket. But if you have two gears that have involute profiles, you're going to get like a constant velocity between the two gears. So it would be possible, for example, to create like a spline and like fit it to an equation. And if you knew the equation of the involute, you'd be able to accurately model like what a real sprocket tooth would look like.
Wait, what does the spine do again? Oh, the spline. Oh, this annoying thing.
Right, that annoying thing. In most CAD programs, you really use it to like fit specific curves. For example, if you wanted to put like an accurate involute curve in here, you'd probably use a spline tool to like fit the curve. I'm not sure if Onshape has like an equation-driven curve
How do you
feature.
stop using it? I can't stop using it.
Usually you can stop just by hitting escape on your keyboard or just hitting the tool again.
Oh
But
my
yeah,
God, that's
for those reasons, I'd suggest maybe not using that tool.
Why is the spline so?
All right, if everyone's caught up to this point, we're going to do a little bit of magic. And that's going to be using our pattern tools. And before I introduce this, I'm going to kind of show you today two different ways that you can create a pattern. And the reason for that is the first way that I'm going to show you right now is called a sketch pattern. And it's great and everything, but it'll have some drawbacks that are going to come up later. And then I'll show you an alternative, which is called a feature pattern, which happens one level up. It happens in like the 3D workspace. And that one is a little bit easier to work with. All right. So what we're going to want now is to select the pattern tool, and it's been a minute since I used this, so I'll have to look for it. Here it is. So it's going to be towards the right of your toolbar. It might not by default be at the pattern feature, but if you do the drop down menu, it's going to look like this one, right? It's going to be a pentagon made out of circles. It's called circular pattern. Looks like this, might be hidden, but it's there.
What does the sketch fillet do? Does it just like make it the edges circular?
Yeah.
Because it looks like a triangle and then it's carving out a bit of it to look like a circle, part of the circle.
So if you remember in our 3D space, 2 weeks ago, we used the fillet tool, right? And that takes your 3D objects, it takes the corners that you select and it kind of rounds them out, like you sanded them over. So a sketch fillet basically does that, but before you go into the 3D workspace. So while you're still in your 2D sketch, it takes your corners and it turns that sharp corner into like a rounded part.
Oh, okay.
And so when you turn it into a 3D part, it'll already have the fillets. Some people like these. I personally am of the opinion that you should avoid them just because it tends to make your sketch complicated. And that's kind of the same reason actually that I'm going to show you how to use the circular sketch pattern feature, but I'm going to recommend that you use the feature pattern feature rather than the sketch pattern feature. Anyway, here it is, circular pattern. Click on it. You know the tool is active as usual because it's highlighted in your toolbar. And the way you're going to go about this is, let's see, I believe you select the two entities which we want to pattern. That's our sprocket tooth. So those two lines. You can see now I'm kind of dealing with the interface of this sketch pattern tool. So it's going to be a bit confusing. It's not quite like anything we've worked with before, but it's not too bad. You can see there's this like white arrow that goes around, and you can see there's like a preview, like a faint shadow of the things that it's going to try to create. You can also see I have a few numbers that show up. Actually just one number, and that's the 3x tool, or the 3x little box here.
Wait, can't you use this tool to like duplicate everything?
Right, we're using the circular pattern tool.
Can I just click left click now?
You can, but I would suggest changing this number. This is the number of instances from 3 to something a bit higher.
36 divided by 12 is 30.
Almost.
Aw.
Actually, yes, I don't know what I was thinking.
Yeah.
You're right.
How do you change the number?
It's a late night.
How do you change the
You
number?
can double click it just like a dimension, right?
Okay. 30.
Right.
Bro, why does it only do it like 1, 2, 3, 4? It only
Right,
does it like 7 times ish.
That's kind of like a limit of the preview. You can see here the last one is dotted, and then on here the second, like the last one is like dotted again.
Is it like the where people write numbers and they don't want to write the entire
right, like dot dot dot. Like just imagine that they're there.
Dot 4, 6, blah, blah, blah.
Right, that's the idea. And so now we're going to hit left click, which you can see on your cursor. The left click has a check mark on it.
Okay, yeah, there's a ton of spiky.
Now we have a ton of spiky, as you say. And the problem is, why are they all blue? They're all underdefined for some reason, even though our first
you
one
have to
was
define them all.
defined it. And you don't have to define them all. That's the thing. If we had to define them all, this would kind of not be much of a time saver because we have to do everything again anyway. And so
if everyone works on their own, they can do it in at most 10 minutes.
I suppose. If you try clicking and dragging one of the points around, what you'll see is that there is this center point here. And that center point is kind of the center of rotation for your circular pattern. Like if you think about your circular pattern, right, there's no reason that the origin of your sketch has to be the center about which your pattern is formed. For example, you might be designing a part where you want to have some circular symmetry of some sketch entity about another point, right? Maybe you're making like 4 different sprockets, one in each quadrant of your coordinate system for some reason. In that case, you'd want the center of your circular pattern to be somewhere else. And that's why Onshape does not by default set your circular pattern's center, its axis of rotation, to your origin. And so all you have to do is click on this center of rotation. You can find it just by doing what I did, drag out one of the blue points, it'll reveal the center point, and then you can just click that, click your actual origin, and use the coincident relation to put them together. And once you do that, everything breaks. What happened? Let's figure this out.
You said everything breaks as sounds like you want it to break on purpose.
Yeah, that's not quite what I want. So I'm not sure right now, I'm not sure what's happening. Usually this works. So let's take a step back. I will just undo. It's possible some kind of weird relation was created unintentionally. So I'll just, whenever I'm in doubt, I just go back and redo the thing that I was doing. So I created my thing and make 30 of these. Whoops, I hit escape.
So can I try to do it?
Yeah, go for it. Maybe you'll have better luck than I do.
So I don't click it before I do the coincident tool, right?
I'm not sure exactly what you mean, but ideally this is what's supposed to happen.
Yay, it worked.
Yeah.
Yay.
So
Everything
I'm not sure
is
what happened
black
before,
now.
but everything should be black.
Yeah, everything is black.
Great. And now you can see we've created our sketch with almost no effort. We have 30 teeth. We've made like a little sun shape, cartoon sun shape. It's not a realistic sprocket.
It's missing 2 eyes and a gummy smile.
Do you have a question, Jeffrey?
Yeah. How do you duplicate them all again?
Sure, I'll go back and show you again.
Circle pattern.
Because as we just saw, even I can have trouble with it sometimes. You click the circular pattern feature, which hopefully you found in your toolbar, and you select the 2 things that you want to copy, which are your lines for your tooth.
Okay.
Then this brings up this interface, like this. Like this stuff all does something. Like this will control like where you start. This will control like how much of the circle it'll pattern it over. But don't worry about those. The defaults are what we want. And then you double click on this number, which is a number of instances, and you change it to any number that you feel is appropriate. You left click somewhere in the background, and that will confirm your use of the tool. You'll say, this is what you want. And then you fully define it just by bringing out this point, which is the center of rotation of your circular pattern. And you make that coincident to your sketch origin. Henry, do you have a question?
How do you make it like not triangle-y and more like rounded?
That is a good question. So how do you think you would do it? Let's take a step back before we made that whole pattern.
Let's see. Going through. I don't really know.
Right, so at this stage, before we pattern everything, once we pattern everything, we're only going to get multiple copies of the thing that we already had. So we're going to have to change something at this step.
How do you
And
unpattern?
I just undid my pattern with Control Z. I think you can just
Okay,
probably
yeah.
just select everything and delete it if you need to.
I just did undo.
What you might be able to do is delete like the pattern relation. I'm not really sure. It works different in every CAD program, but for reasons I'll show you later, sketch pattern isn't even the best way to do this, in my opinion. But to answer your question, if you don't like the triangle shape, which is understandable as it's not really that accurate or good looking, in my opinion, maybe your unit cell can be a different shape, right? So I won't go to the trouble of like fully defining this, but hopefully with the skills that you have, you're able to fully define it. You can imagine, like, for example, my unit cell, the thing that I'm going to pattern, I might want to make it look something like this, right? Maybe like a trapezoid, and maybe I want another like gap between my trapezoids. You can see if I pattern something like this, and I selected these guys, and I'd select that, the shape I would get would be slightly more realistic, right? Whoops. I'm not sure why I had two sketches there.
Can we do that?
For the time being, if you want to do this on your own.
Oh, whoops.
But
So we're not gonna do it right now.
yeah,
Oh,
I'd say just stick with the circle for now, and we'll move on with the demo.
so is this how you make it circular-y?
So you do something like this. You just make your unit cell the first thing that you created, the shape that you want. You can like fill these, for example, if you want to make it rounded. You could do the whole profile using some combination of arcs or splines, but for the sake of simplicity, we'll stick with our.
Is there like another way you can like round it other than that?
So I'm not really sure what exactly you're looking for in terms of like rounded. Like, I don't know what part you want to make rounded, but with the tools that we've learned so far, you should definitely be able to, you know, I'm sure you can find a way to do it.
Like the one in the bike track where it's like where the triangles, the tips are circular partly. Like
Right. So what you could do is like use your lines, for example, and like draw like a shape for a single tooth, and you would draw this like over here on a, instead of the triangle, right? You draw your shape.
okay. Are we supposed to go back? Are we supposed to go back to like the full circle thing now?
So what you'll do now that you have this sketch, right? You can go to your 3D workspace, like hit check mark on your sketch, and what you can do is extrude it.
What about like the inner circles?
We'll do that in a separate feature, and I'll use that to demonstrate another tool.
Okay.
Which,
now I need to do the circular thing again. And then multiply this by 30. Yeah, multiply. Yes, please. Thank you. Question, how do you make it all black again? I forgot.
right, so I ended up redoing mine because I don't remember how to delete the sketch pattern. But what you'll probably need is to make them equal.
Oh, the condescend thingy. I remember now. Click, click. Okay, yay, it's all black now. Extrude. Wait. First go to sketch. Complete the sketch. Extrude. Complete the extrude. Okay, it looks so weird. It's just a thick layer of a circle with triangles on the outer edge.
All right, so let me catch up real quick. And what you'll find when you do this, when you extrude, you recall that whenever we had multiple sketch profiles to choose from, when you're selecting your sketch regions for your extrude feature, you have to click every single one of those triangles, basically. And that's kind of not what we're going for here. We're trying to do things fast and quickly.
Where are the circles again?
What do you mean circles?
Like, weren't there circles inside it?
Oh, the pockets we will do afterwards.
Can I
The first point I want to make is that if you use the sketch pattern feature, what you're gonna have to do is click every single tooth. And even though for this, you could do that and it'll only take you a couple minutes.
No,
you
I'm
can
not.
imagine.
When I did my extrude, I didn't have to do anything.
Interesting.
I just had to, it just came up like, yeah. So then I changed it to 1 centimeter in width because then it looked better. So that's basically all I had to do.
Right, okay, so yeah, it turns out you can actually just do that. So what you do is you take your extrude tool, instead of clicking regions, you can actually just click on the sketch and that'll bring up everything. So
Oh, I did that on accident. I was
Uh,
trying to go to my extrude, but then I forgot to click the check mark on my sketch. So I went back to my sketch to click the check mark, and then I went to my extrude, and then it was fully finished.
right, so yeah, that's actually pretty good that you discovered that. So when you have like the sketch selected already and you hit extrude, I think it might automatically populate the field with the previous selection that you had. So actually, yeah, this works. And so you can make the sprocket like this. What I was going to suggest is you can also use a circular pattern feature. So I guess no need to follow along for this one. I'm just going to show you and hopefully put the idea in your minds that this is a thing that exists, but don't worry about it. Let's say, for example, that, instead of doing that, I just extruded the circle. And let's say I made another extrusion. That is a single triangle, right? Now, what happens is I can do pretty much the same thing that I did before. It's just that now the pattern is occurring at the feature level instead of at the sketch level. And so for entities, I select like the part that I want to copy. And for instances, it's the same idea. I type in 36. For your axis of pattern, you can just select the outer circle. You can also select, I believe, cylindrical faces, or you can select lines. But in this case, you would need a line that kind of goes through the axis of your sprocket, which I don't have. And so it's the same idea. It's just that it's a lot more convenient to change later because I have this whole entity in my feature tree now, and I can just go back and edit it. Maybe I only want 30 teeth in my sprocket. I can reduce the number just by changing a number here instead of going back into my sketch.
Your spikes are 10 degrees.
I may have changed it. It may have been something different before.
Because you did it 36x. I only did it 30.
I probably ended up changing a number somewhere in there. Don't worry about it.
Yeah, it is 10.
It won't matter. And so the idea is like, it's harder to edit a sketch pattern than it is to edit a feature pattern, just because the feature pattern comes with this whole new, like, it has its own dialog box. It's easier to see where you need to input things to change it. So that's the idea. Just know that it exists, but you don't actually need to use it in this case. So don't worry too much about it. Just know that it's there.
Inner circles?
Right, now we're gonna make those.
I wish we just make like we made a few circles on the sketch, and then all we had to do was click like make them not filled in.
Yeah, so actually you could just do that. Like if I make a circle there, it'll come up as a hole in my part, right? And the only reason I'm not going to do that is to show you a new feature. So let's go back, and I'm going to create another sketch on my front plane. And this time the sketch is just going to be the pockets that I want. So for the sake of simplicity, maybe let's say they're just going to be circles.
How are you in a sketch and it's fully defined?
My sketch is not fully defined. You can see the
No,
only
I'm
thing in my sketch is the circle, and the
So
circle
I'm
is blue.
saying, how are you in a sketch and you still have that 3D thing?
Oh, I made a new sketch. So yeah, you can have as many sketches as you want, and your sketches can be in different planes. They can be in custom planes that you make. Yeah, maybe I didn't make that clear before, but you can always create a new sketch if you want to. And you should also always be careful, like know which sketch you're working in, right? Because that can sometimes cause problems. But what we're gonna do,
So we are making circles,
yes.
but how do we make it even? Oh, okay.
So let's say I do something really simple, just like that. Uh-oh, what's happening?
We're supposed to do that, right?
Right, I do want you to make some pockets on your sprockets.
But I thought there was like a pocket in the center and there was like.
Right, that is true. So yeah, we can also make the center board while we're here.
But don't you think that the side one is too close to the middle one?
Yeah, it probably is, and it's pretty easy to change that. I'm just tossing some numbers in to see what I'm working with. So just make up whatever numbers you feel like. Maybe I'll make this one a bit smaller until you're happy with how it looks. And we're going to do another sketch pattern using the circular pattern tool. And I'll just go ahead and make a few copies of just the outer circle. And so hopefully you've gained some experience and you can do this on your own and it all works and it doesn't turn red and say that it cannot be solved, and instead just becomes black and is happy.
One thing for when you extrude it, do you extrude the circle, right?
So when I did this part to extrude the whole sprocket itself, if you select just the circle, what's going to happen is it's just going to extrude the circle.
Oh, okay.
Yeah, so what you want to do is just click on sketch 2 in your feature tree on the left here, and then it'll select everything that's in that sketch.
Oh, okay. And then extrude it.
And so once you've made this next sketch, which is a bunch of circles, I want you to have one central circle in the middle, and that's going to be the bore by which you hold your sprocket. And the other ones are just pockets. So they're perhaps decorative, not strictly necessary holes that we put in there. And you can.
How do you make like holes in random?
that.
How do you make like holes in random positions like equal to everything else?
So these, if you're talking about these circles, I use my sketch pattern here. my circular pattern.
Oh, okay.
And so the new tool that I'm going to introduce, it's another 3D tool, and it's not really a new tool. It's the same old extrude tool. We're just going to change one of the options a bit to make it do something slightly different. So, like as was pointed out earlier, someone said you could just draw the circles in the first sketch that you do, and it just won't extrude that part, right? It'll create the holes, and that works. And for the most part, there's no real reason you couldn't do that, but sometimes it is good to have different features of your design in different sketches for the sake of readability, right? Just like we use construction lines to make our sketches more clear, especially to other people who might look at our CAD. It's sometimes good to have different sketches for different things. So like one sketch for the actual sprocket, one sketch for the pockets. And that can be clear for someone, especially if you actually name your feature tree items properly. So I could call this like my sprocket and teeth sketch. I could call this my pockets sketch. All right, so once you made that pocket sketch, we're going to open up the extrude tool again. And here we're going to change one of these things here. So by default, we've been using new and sometimes add. And so new and add, they just create, they create material, right?
Why are these not turning black? I don't know why they're not. Like, I don't know why these things are not turning black.
If your first circle is black and the patterned circles are
Oh,
not
wait,
black,
never mind. I got it.
great. All right, so as I was saying, extrude, you have new, which is the one that we use by default. Whenever you make a new 3D object, it's always going to be new. Add is what you use when you want to create another thing, right? Like Onshape will select this one by default generally whenever you're going to be using it. So basically, instead of creating a new body, I think it's just like creating well, my guess is that it's basically the same as like merging the new extrusion that you make with what you had before. Although I'd have to play with it a bit. What we're actually going to select here, though, is remove, which is the third tab here. And as you can imagine, what remove is going to do is kind of the negative version of what the normal extrude does. And so if I go over to my sketch, and you might have to turn it around. Whenever you look at a sketch and you see that it has these dashed lines, that often means that you're kind of looking at it through something, right? Like the sketch is actually behind the 3D object. So I'm just going to turn around. You can see now they're solid lines. And I'm going to click on my circles. Or you could also just click on your sketch that you made for the pockets.
Can you briefly do that again? Because I just finished my holes because it took me a long time to make the holes because I couldn't figure something out.
So extrude, we're opening it up, same old extrude that we've always used. And the only thing we're going to change is that we're going to go to remove.
And then click on the holes?
You can click on the holes. You can also just click on the sketch. And you might get an error message that says selected tools and targets not intersect. Or not really an error message,
it
but like a
doesn't
warning.
do anything.
Right. So it's not going to do anything if that's the case. But what you can do is you can flip the direction of your extrusion so that it goes through the original part that you made. So you can hit this arrow. You can also drag this arrow. You can drag this arrow like that.
It still does nothing.
or you can just hit this arrow here. And what you want is for kind of the arrow to be going through your part. And what you'll see is that it previews your sprocket with holes in it.
It just looks like it's been out. So do I accept that?
So if you have something that looks like this, where the preview has holes in it, that's what you want.
My bike sprocket looks really weird.
And then one thing I'm going to explain here is what blind means, right? So up to now, we've always just used blind as our default setting here for our extrusions. And what blind means is just that the end condition where your extrusion stops is blind, right? It doesn't care about what's already there. It just follows the number that you put in here, and it just goes up to that number no matter what. It blindly goes up to 3.01 inches, or like, I don't know, 5 inches, whatever number you put in there, it blindly goes there. There's some other options, and they kind of are self-explanatory.
Wait, how did you name these sketches?
I'll show you that in a second. But instead of blind, for example, you can do up to next or up to face, and that
Oh, I see, I found it.
will just stop it once it gets up to the next interesting feature. So instead of blindly going in a certain depth, it'll kind of look around, see what's there. It goes up to the next thing, which is the opposite side of the sprocket, and it'll stop there. And the reason this is preferable sometimes over doing blind is sometimes you don't know how thick your sprocket is, right? Maybe instead of a sprocket, I'm going to make like a long extruded sprocket shaped tube, and it's going to be 10 inches long. And suddenly my blind extrusion isn't going to be long enough to cut through the whole part. But if I did up to next, it would just find the next feature, which is the end of the tube, and I'd be good to go. So that's that. Basically, the only thing we changed is we are doing remove now, and that will do the negative of what extrusion does. Instead of adding material, it removes material. And so that's our finished sprocket. So if you have any questions up to this point, let me know, and I'll give you a bit of a overlook onto the next couple of things we're going to do, which is the remaining parts of this device.
So for the holes in the middle, it doesn't really matter what shapes those are, right?
These pockets are completely up to you. You can make them whatever shape you want. For the one in the very center, I would recommend making it a circle, just because it's going to interface with another part that we will be making. Yeah. So at this point, just take a moment in the bottom of your tab here. I would go ahead and rename Part Studio 1. Rename this whole tab into something sensible like Sprocket. And as we create more part studios, it's going to be helpful just so we know that it's a sprocket instead of Part Studio 1, 2, 3, and so on. And now what we're going to do, we're going to create a second part studio inside of the same document. And the way you do that, you have a plus sign in the bottom left-hand corner of your interface here. You hit that, and you create part studio. And you can see that it automatically takes me to my new part studio.
What are we supposed to do in this one?
We're going to make the remaining parts of our machine.
Oh, the thingy thing.
Yes. So
Wait,
on that note,
by the end, will we be able to turn the thing?
yes, that is the goal, and we will get there one way or another.
Wait, will the outside rotate?
It'll be such that you can like click and drag the handle, and it'll turn the sprocket.
Yeah, I know, but well, like it will turn the sprocket.
Yes,
Okay.
that's the idea. So let's do a quick like inventory of what we're going to need to make. Right, the sprocket was the obvious one. Now that's taken care of. Now let's
handles.
All right, handles, great.
Part that holds the handles together, that goes through the center hole.
Okay, we're gonna have handles. We're gonna have, I'll call that the shaft.
The the triangle thingy that holds that holds everything together.
Sure, I'll call that the base.
Is there anything else? I don't think so.
That's the main thing. When you say handles, I'm going to treat the handle as just the part that you put your hand on, right? The grips. And then I'm going to
No,
create like one more part.
the things you put your feet on.
I guess in this case, yeah, if you're thinking of it like a subsystem of a bike, yeah, you would put your feet there and not your hands, most likely. I'm going to create one more part just for this part that connects the shaft to the handle, and that's this link. So those things plus our sprocket are all the unique parts that are in our assembly here.
Did you do a bike sprocket with every season? Like in CAD 1?
I've done a few versions of this class and they've all gone slightly differently. I do try to do the sprocket first, and if we have time, we also do the ellipse trammel here.
What about
But
the house?
I've never done the house with my classes or the phone stand. I find it's
Is this really easy or something?
It's good practice, sure, when you're like first learning how to do CAD, but in terms of assembly, there's not. I think it's more interesting of an assembly to do something like this where you have some rotating components and such. And the ellipse trammel is definitely very interesting. I'd recommend just like thinking about this and trying it out, even if we don't get to it, which it seems like we may not, probably won't. But so now that we have that list that I typed in the chat, you can look at this picture, think about how you would go about creating the models for each of these. Some of them will be pretty simple, some of them will be a bit more involved, but none of them will use anything that we haven't really done so far. Like you don't need anything new, like a pattern to be able to make these. So if you want, take some time over the week to try and make these, and you can, yeah, have a go at that. We'll probably get through, like I'll try to push us to get these through pretty quickly, and then we can start working on the assembly. And yeah, I'll definitely make sure we finish this assembly for this class session. But since we are coming close to the end of our time, if you have any general questions, if you have any questions about the class or in general about
I have a question.
things, yeah.
Do you have like a 3D printer to recommend? Because yeah. Do you have like a 3D printer to recommend?
So personally, I'm not much of a like hobby 3D printer. I haven't done a lot of 3D printing on my own, but these slides, which I can post, they have some recommendations for like maybe budget level, like hobby 3D printers. So
sorry for the interruption. Harry, are you from Maryland?
I was in Maryland. I'm in McLean now.
McLean right now. Okay, because the reason I'm telling you is because we have a 3D printer in the center. So you can, bring your design and come to the printer in our STEM center. Yeah.
Oh, okay. Thank you.
Yeah, I can give you address.
Thank you.
Sure, you're welcome.
okay, well, with that, last call for any other questions. And only thing is, think about how you make the rest of these components. That's the shaft, the link, the handles, and the base. Come back with ideas next week, and we'll hopefully be able to knock out the rest of the components in one class and then start assembly in our last class, if not next class. Do you have a question, Jeffrey?
Yeah, for the pockets, what tool do you use again?
For the what?
For the pockets in the sprocket.
Right, to cut them out, we use the extrude tool. Just instead of add, we do remove.
Oh, okay.
And you have to make sure that it goes through the direction that you, like make sure the arrow is pointing into your sprocket rather than away from it like it is right now. So this way is what you want. Anyone else? Not, have a good week.